Hi everyone, I hope you are doing good. So till now we have understood and discussed what is MMX, how the data looks like, and some bits and pieces of MMX. So now as the last step of the MMX project series, I'll be discussing the modeling stage where I'll discuss some of the machine learning models, which in fact some industries use to give suggestions to the clients. So without any further wait, let's get started. I'll share my screen. So to save some time, I have done all the coding part, and in this video, I'll discuss each and every step that I have performed here, right? So as I go ahead in this video, I'll give you some tips which I think you should incorporate whenever you are working on any data science project, right? So you can maybe take a note of it. So starting with uh, the libraries, right? So why do we need some libraries? These are the pre-coded, or you can say some repositories which some brilliant minded people have already coded for you and made your life easier, right? And made our life easier. So we can directly import those codes and use as we need, right? So I have imported pandas, NumPy, Matplot for the visualization part, Seaborn for the same, and sklearn for the machine learning part. Let me just remove these things, and I'll import when I need it. Sklearn, okay, I don't need it. So these are the main four libraries for any exploratory data analysis. And yeah, so this is the part where you import the libraries, necessary libraries, which will help you explore the data, right? And then the second step comes where I'll read the data. So my file was in Excel format, so I have done p.read Excel, right? And then with the head command, I have seen some of the top rows of my data, right? Where I can see the data, the data has these number of columns. I think we have discussed this data in the previous video. If you haven't watched, you can go and see. Right, so this is how our data looks like. Um, we have numerical columns, we have comparative sales, holidays, events, and revenue column, right? So just to explore the data, what I have done is I have seen what is the starting date and the end date of my data. So here I can see the starting date of my data is 2015 and 2019. So I have 4 years of data, right? So this is the first thing. And then as the second data check or exploring data step, you can see how many, if there are null values are there or not in the data, right? So the simple way is to do the info, dataframe.info, which will tell you how many records are there for how many null and non-null values are there. So here I can see that the data has 208 shape, right? So the row count of the data is 208, and I can see for each of the column we have 208 non-null values. So from this, I can say that there are no null values in the data, right? And similarly, for that, I have done is any.sum, right? From here also, I can see that there are no null values present in the data. But even after seeing these two things, we have some NA values in the events column, right? NAs, right? So if you directly use this column and give it to your machine learning models, the model will give you some errors because they will not handle the categorical data. You have to convert the categorical columns to the either dummy variables or some kind of ordering should be there, right? So this is the check or the suggestions that you shouldn't rely on any of the method on any of one of the methods. Like you should use couple of things to make sure that your data doesn't have any nulls, right? So what I have done here is I have so that events column has three unique values, NA, event one, and event two. So what I have done is I have given NA as zero and event one and event two as value one, right? So after applying lambda function here, I can see the unique values of this column as zero and one, right? Don't worry. I'll share this notebook with you. Uh, I'll give you some of the links, or I'll upload it to my GitHub. Right. Right. So now I'll drop some of the variables which are not needed for my analysis. Um, yeah. So I don't need impressions data, and I'm also excluding the comparators data. And the reason why to exclude these columns is because by MMX, my objective is to find out the efficiency of each of the media channels, right? So that I can allocate my budget according to that. So now you'll ask some questions like, how can I use the impressions data and where will I be using the impressions data if I have any? So for those will be used in the MMX only, but to find out the CPM or the cost per impressions in terms of how much I have to invest to get some of the impressions, right? And competitor sales, for now, I have excluded from my data, right? So to get the efficiency in terms of how the media channel is doing basis what I'm investing on it, I'll be using the spends column only in my analysis, right? So those are some steps for data exploration. I'll give you some outlines here. So those were some of the data exploratory steps that should be done to see how the data values looks like and if there any thing that needs to be done, right? And then now we will jump on to this step that is data checks, right? So now I want to see if the variables in the data has any anomalies or not. So for that, what I can do is I can see the describe here, and in particular, I am interested in the min value and the max value. Right. So by minimum, I can see that if there are negative values of a column present there or a maximum, which can be maybe infinity in some case, if there are anomalies present in the data. So directly from describe method, I can directly see if there, there are anything that needs to be done. Right. So here I can see nothing is there like that. No anomalies present in the data. Right. And then comes check number two, which is the multicollinearity. So multicollinearity, I hope you guys know, that means that if there is any relationship between the independent variables used in the data. So what I mean by that is, let's consider an example of education and salary. So in general, what happens is if you are uh, doing more degrees or maybe doing more courses, then your salary will increase, right? So there is a positive relationship between them. So that is called a positive relationship or collinearity, positive collinearity. Similar to that, we use a term called multicollinearity, in which more than one variable or two or more variables are correlated with each other. So what happens is we have to deal these kind of variables before giving our variables into the model, because eventually what happens is the model, if model is giving any results, those will not be reliable, and that can be proved statistically. And that is a session, that is a thing for another session, right? So I'm using here a variance inflation factor, right? So this is a linear way to linear in terms of mathematically in I'm saying linear, right? So this is a linear way to see if there is any relationship between the variables, right? So this is a uh, code which to find the variance inflation factor. And note that I have excluded the date column here, right? And if I see here, uh, I can see that the VIF values are very low, right? Except these ones, search S and search clicks P and revenue, right? So what I've done is, since these two variables have very uh, like collinearity is there between these two variables, I have excluded one of the variables from the model, right? Like search click B. And now the variables that I have left over, they are very they have very less collinearity with the other variables, right? So these are fine and I can go ahead with them. Right. And to do some quality check of the data, I have seen if spend and revenue column, and similarly, I can do for other columns as well. I have checked here that if my spend data has negative values, which shouldn't be the case, right? And similarly for the revenue column, revenue shouldn't be less than zero, right? And for that, I have used the describe method. Here I can see minimum and maximum values, right? And then date column, yeah, this is date column format. Yes, so the date column format is fine. It is in the datetime format, right? So now the next part is the modeling. We have our data ready. We have done all the quality checks. We have performed all the uh, cleaning part is done. Now we will jump on to the modeling part. So, before applying or using any machine learning models, we will first have to do some kind of transformations on our spend data. And the reason why is, what happens is, let me just discuss this APL transformation, and by that you will get a better understanding of why we do such transformations. So there are three kind of transformations which are generally done. Those are called APL transformation. And by A, we mean add stock, P mean power or saturation, and L means lag. So what add stock means is let's say if you are seeing an ad today, then how much are you or how much do you remember the ad next day, right? So our memory of the ad that which we have seen is diminishing period by period. So that is what we are trying to incorporate using this equation, right? This is the equation for that. And hill saturation means that let's say if you have read the concept of diminishing returns, what happens, what it says is, if you are investing after a point, after an inflection point, the impact of that spend diminishes, right? So that is what we are trying to uh, handle using this equation. And the lag means that if you are showing some ad on the TV today, then its impact will be seen from how much, like from which time period. So let's say if L is equals to zero, lag is equals to zero. That means that if I have shown you the ad today, then you will be impacted by that ad today only. And similarly, if I take the value of lag as 3, then if I have shown you ad today, then you will be impacted by that ad, or maybe purchase some items after after 3 days. That is what lag means here. And for this analysis, I have uh, chosen the value of L is equals to 0, which means that once you have seen the ad, you will directly go and buy the product, right? So this is what this huge couple of lines of code is doing, right? And then once we have defined our code, it's now is the time to apply it on our data, right? So I have defined this. These are my media channels, right? And one by one, I'm applying these transformation, add stock transformation with alpha is equals to 0.5. This is the static value. Please note here, I'm giving a static value here, right? And similarly for slope, I'm giving a static value, saturation also, and then I'm applying this code which I have defined here, add stock and saturation on my spend data, right? And now, yeah, and then I have appended the data, this transform data to my original data, and this is how it looks like. These are my new columns, right? So at this step, we have the data ready. We have done all the cleaning, validation. We have done some transformation, which is required for MMX. And then I would like to give you a suggestion here that here I have used a static value for each of the parameters. One another way could be is to use some optimizers which will directly or automatically find a value of the parameters, right? Which will minimize my mean squared error, right? Which will minimize my objective function. So these are the random values which might not minimize my errors, right? And which I'll be showing you in couple of codes from here, right? So these are some random values which might not minimize the errors, but if you use some kind of optimizers which will automatically find some of the hyperparameter values which will minimize my objective function, right? So now, this is the tip I have mentioned here, that another approach could have been using optimizers which will find the values of the parameter instead of choosing default values which will minimize my objective function, right? And now I'll use the machine learning model, the linear regression, right? For that, I have used the sklearn library, some couple of metrics here, mean squared error and R square, and then I have used train test split to divide my data into two chunks. First is the training and test data. So the size of my train data is 80% and test data is 20%, right? So I have directly import. uh, inserted the data into the algorithm, you can see it's very simple, just a couple of line of codes. But the main thing is to understand the analysis and the data, what the data is saying, and how you do the processing and transformations. Why is it done? That that is more important, right? And then from this predict method, we can see that model coefficients are these ones, and intercept is this, and R square is 47%. Please note that why R square is 47% here only is because the values of R square and squared errors is very small in case of R square, and errors are very huge because the values which I have chosen for the for the parameters of the add stock alpha and the hill saturation, half saturation and slope S is a random value, not a optimized value. I'm sure that if you use some of the optimizers to find these values, or maybe you can just hit and trial and find the values of the optimal values for these transformations. I'm sure that you will find something good, and your R square and the errors will be small, right? And here you can see I have given a note that negative impact of spend is not. Here you can see that one of the variable has a negative coefficient, which ideally shouldn't be there, because when I'm spending anything, when I'm spending even a single dollar on any advertisement of a product, then the maximum that should happen is either the sale is not happening or the sales are positive. But in an ideal scenario, this is the ideal scenario. Maybe in some rare cases, some negative things can happen. So this is why we generally don't rely on linear regressions, because we assume that if I'm spending a single dollar on advertisement, the impact of that spend is positive, right? So this is the reason we avoid using linear regression, or maybe what we can do is we can put some constraint on the coefficients, which will limit the coefficient estimation range, right? So this is the thing, and I know I have given you suggestions a lot, and each of the point is can take maybe a couple of lectures to understand and deep dive into it. But I'll see if I get some time, and you can maybe ask if you are not getting the points, right? So now what are the next steps from here? We know that linear regression can't be used, and we I have previously mentioned that you can use linear regression, but you have to give some bounds on the coefficient. Another thing which is crucial in the MMX is the multicollinearity, which I have discussed previously. There I have used variance inflation factor, which is nothing but the R square only, some transformation of the R square. And if you see R square, how R square is calculated, it's more about a linear relationship or a linear method mathematically, right? So it might happen that a couple of variables, independent variables, has non-linear relationship. So how do we deal with that, right? So we cannot see the impact of non-linear relationship using various inflation factor. And I hope I have discussed why can't we directly use the variables if the problem of multicollinearity is there in the data, right? So to to identify that, how to identify it, if there is a non-linear relationship is there, we can directly see it using a pair plot, right? We can visualize it, right? And within pair plot, we have a different kind of, we can plot different kind of charts, can use scatter, KD, histograms, and this REG, right? So from this chart, what we can conclude is there is no visually s- non-linear relationship, right? So there is no need to incorporate non-linearity into the model, and that saves our life and makes our life easier, right? So um, what could be done if it were the case? So what happens is we will use the ridge regression, right? So what happens is what ridge regression will do is ridge regression will try to gives give or compress the coefficient or the estimates of the variables such that the model results are reliable, right? Even though we are including the multi-collinear variables into the model, right? So no clear sign of non-linearity relationship, but if it were to happen, then we would have used ridge regression to incorporate non-linearity and handle synergy interaction effects. Right, so this is it. I know that this is a big this is a large recording now, but this is all